Okay, here we are at section 7.2, the quadratic formula. This is a nice section, fairly easy, except maybe before we get to our second objective of solving application problems using the quadratic equation, and the formula too for B here. All right, you can see in objective A, it's solve quadratic equations using the quadratic formula. Fairly easy. I hope you find it to be easy. And let's find out. All right. Okay, herein lies the quadratic formula. Remember what our purpose for this is. It gives us yet another way to solve quadratic equations. And this way we can also solve equations that are imaginary, with imaginary numbers, imaginary solutions. Whereas the traditional way of factoring doesn't work. So we'll be able to complete the square and use the quadratic formula. You could use the quadratic formula for any of these, actually. All right, so what's the quadratic formula? It is negative b plus or minus the square root of b squared minus 4 times a times c, all divided by 2a. And here's our ABCs again that we talked about. Remember, it comes from the standard form of the quadratic expression of ax squared plus bx plus c equals 0. So here's where our ABCs come from. And that's where the appropriate letters will be, the numbers representing the letters will be placed. Okay, and remember, plus or minus, we're going to have two answers because one's going to be negative b plus the square root of b squared minus 4ac, and the other answer will be negative b minus the square root of b squared minus 4ac over 2a, of course. So you can derive the quadratic formula from this. This will get you this. And I made a separate video of that on my channel if you care to look that up or check that out. Kind of interesting to see how that this evolves into this up here. Okay, let's go to an example. All right, so how do I go about attacking these? So I've got, it says solve x squared minus 5x minus 6 equals 0, quadratic equation. It's in standard form already, so we can look at this and label what a, b, and c is. So I could say a equals 1, the coefficient of x squared. B equals negative 5. Don't forget our signs preceding the numbers. And C equals negative 6. Okay, so when I plug it into my formula, I can calculate this with a little bit of ease. All right, so let's see. However, we're looking for exact answers, not decimal approximations. So remember that. So let's see. If I've got negative b plus or minus the square root of b squared minus 4ac, all divided by 2a. And you can keep this formula with you for every problem and, you know, kind of plug in the values. All right, so I got negative b, and b is negative 5, so that's going to be negative 5, because that's what b is. And then I'm going to have plus or minus, then let's see here, the square root of b squared. Well, that's negative, so that's going to be positive no matter which way you look at it. So that's going to be 25 minus, and then I've got 4 times a, which is 1, and b, which is, c, which is negative 6. Okay, all divided by 2a, and a was 1. So it's 2 times 1. I usually like to take just work with the numerator because that's the most congested. of the two positions, numerator, denominator. Denominator is easy to figure out. All right, so now let's go up to the numerator now and rewrite this. So that's going to be positive 5 plus or minus, then what's the square root of what's inside here? All right, this is 25, and this is negative 4 times negative 6, so that turns to positive. So this is going to really be 25 plus, and it looks like 24. Negative 4 times negative 6 is positive 24. And then inside the radical here, I'm going to have 25 plus 24, which is 49. Okay, and that's all going to be over 2. All right, so now I can transfer this down this way, and I'm going to say this is going to be 5 plus or minus the square root of 49 is 7, and that'll be over 2. And then I can get my answer now from here to say, well, 5 plus 7 is 12, and 12 divided by 2 is 6. So that's one of my answers. The other is going to be 5 minus 7, which is negative 2, over 2, which is negative 1. And these are my two solutions for that using the quadratic formula. Okay? Okay. Here's example 2. And I'm looking this over and I'm seeing that I got 2x squared here. It's not in descending order yet. I've got to bring the right side over to the left. So that means I'm going to add 4x and subtract 3 on both sides. So my left side would be 2x squared plus 4x, and that's minus 3. Now it's equal to 0. So I've got it in the right form I need, the standard form. So now I want to list my values for A, B, and C. So A equals 2, B equals 4, and C equals negative 3. Okay, so now I'm going to plug that into what I need for negative B plus or minus square root of B squared minus 4 times A, which is 2, times C, which is negative 3. Okay, it's nice to see the two negatives there under the radical sign, because you know that's going to change to positive. To alert you ahead of time that you're going to have a positive number under the radical sign, or sometimes a negative number under the radical sign. And this is all over 2a. That looks like a 6, but it's a b. All right, now we'll fill in everything we need. All right, so I've got negative b, and b is 4, so that's negative 4. I'm going to change colors here. Negative 4 plus or minus, and let's see, I got the square root of b squared. So that's going to be 4 squared, which is 16, minus 4 times a, which is 2, and times c, which is negative 3. Okay, I'm just going to do the numerator right now, then I'll divide it by the 2a, because that's going to be 2 times 2. I know my denominator is going to be 4 in the bottom. All right, so let's do this. And I've got 16, so I'm going to do this right side of this discriminant here. I got negative 4 times negative 3 is positive 12. 12 times 2 is 24. So that's going to end up being 16 plus 24. And that's going to give me 40. Okay, so I'm going to now, how about if I simplify that square root of 40? Shall we? Okay, so let's see, how am I going to do that? I'm going to take the 40 and factor it. That'll be 2 times 20. And the 20 I can break down to be 5 times 4. And then I can see I'm going to have the square root of 2 times 4 times 5. Okay, what have I got? I've got the square root of 4 is 2, so 2 comes out front, and what's left underneath the radical is 2 times 5, which is 10. Okay, did I get that right? So this is going to be negative 4 plus or minus, and this part here ends up being 2 root 10. Okay, and that's all going to be divided by 2a, which is 2 times 2, which is 4. And there's almost my answer, but I have to simplify this. So how can I simplify that? I could factor out a 2 from the top here, or I could rewrite this to be negative 4 over 4 plus or minus square root of 10 over 2. If I left it like this, then it would be negative 1 plus or minus root 10 over 2. And there are different variations here for that problem. And you'd have to leave it in this form if you were to do that. So this form's okay. This one needs to be simplified. So this is the answer simplified. And there are other ways of representing this. Okay, so that's it. Done with that. Here lies example 3. Now our first step here is to get the equation in standard form, so that just means I'm going to add 7 to both sides. And when I do, I get x squared minus 6x plus 7 equals 0. Now I want to list my values for a, b, and c, and this time I'm going to go down this way. I'm going to say that a equals 1, b equals negative 6, and c equals 7. And now I'll use my quadratic formula. We know it to be negative b plus or minus square root of b squared minus 4 times a times c, all divided by 2a. And fill it in. So b is negative 6, so that's just going to be positive 6, plus or minus. Then I've got this square root of stuff. So let's see, what's it going to be? Well, it's going to be b squared, which is negative 6 squared, which is 36, positive, minus 4 times a times c over the 2a. I'll worry about that later. Now I just have one negative here. So this is going to be 36 minus, and it looks like it's going to be 28. 36 minus 28. And that is going to give me 8. So I'm going to have the square root of 8 inside the radical. Okay? 36 minus 28. So it's going to look like 6 plus or minus the square root of 8. Can I simplify the square root of 8? Square root of 8. It looks like 2 would come out and 2 would stay in. So this will be 2 root 2. And that's going to be all over 2. Like so. Okay. Whoop. We've got that, and now at this part I'm going to show you something else, how to solve this problem a different way maybe. I'm going to look at this top numerator, which is my answer, but I'm looking to simplify. And now I want to factor out the 2 in this case. I want to factor out the lowest common factor. So this is going to be, I'm going to take a 2 out. If I take a 2 out, divide back what's left over. 6 goes into 6 divided by 2 is 3, and that would be plus or minus 2 root 2 divided by 2 is root 2. And now that's going to be all over 2. Okay, so what happens? The 2's cancel out, and this will be your answer here of 3 plus or minus root 2. And I believe that is going to do it for that problem. Satisfactory answer. Okay. Okay, here is example 4. And guess what? We have fractions. Wow. So the first thing I want to do is get rid of those fractions, just how the problem lies. All right, how do I do that? I want to get my denominators to be the same. That's how we've been doing it in this class. So I want to continue to do it as such. So if I want to get this, remember the x's here go with the numerator already. It's written in the middle, but we know it's x over 1. So I'm just concerned about the 10, the 5, and the 2. And when I want to get this 5 to be a 10, I want to get all my denominators to be a 10, I'm going to have to multiply it by 2. So I'm going to multiply top and bottom by 2. All right, this 2 to get to be a 10, I have to multiply it by 5. So I'm going to multiply top and bottom here by 5. Okay, put my little dot there. All right, so what happens? I end up with, my denominators are going to be the same now, so I'm going to end up with 1x squared minus 2x. That's negative 2 times 1 is negative 2x. And then that's going to equal, what have I got there? Negative 5. My denominators are the same, so I can just solve this equation using the numerators. And this is where I'm at so far. I want to put this equation now in standard form. Okay, if I put this in standard form, it's going to look like x squared minus 2x plus 5 equals 0. Now I'm okay. Now I'm going to list my values for a, b, and c, and a is going to equal 1, b equals negative 2, and c is going to equal 5. To be plugged into negative b plus or minus the square root of b squared minus 4 times a times c over the 2a. Okay, let's plug them in. So negative b, and b is negative 2, so that means negative 2 plus or minus root of b squared, which is going to be 4, minus 4 times a, which is 1, times c, that's 5. Oh, I see a negative number coming. Okay, that's fine. I know it's going to be over 2a. 2 times 1 is 2. So let me figure this out here first. So this is going to be 4. I'm sorry. Not 4, but 2. Positive 2. Plus or minus. And this is the part I want to figure out. So this is going to be 4 minus, what is this, 20? That equals negative 16. And I'm going to have the square root of negative 16, which will all be over 2. All right, how about this simplifying part now? I've got an I that's coming out here. So how about if I go 2 plus or minus, and this is going to be 4i. Square root of 16 is 4, and the square root of negative 1 is I. And I'm going to put that over 2. And then we can simplify this. Let's factor out a 2 from the 2 plus or minus 4i. What's left over? 1 plus or minus 2i. All over 2. This is the other factoring way of simplifying. Okay, the 2's cancel out, and I'm going to have 1 plus or minus the square root of 2i. No, I didn't say square root. 1 plus or minus 2i. And that's what we get from that one. Okay, and here is our answer for that one right here. Okay, example 5 presents us with a little more of a challenging problem. As I'm looking at this problem, I'm wishful that -4 was a 0. If -4 was a 0, then I could solve this already. It's already been factored. But I'm a little bit confused what to do, so what I'm going to choose to do is to multiply these two together and bring that -4 over to get it equal to 0 in an easier manner. Okay, so let's let's multiply this left side. So this is going to give me what? 2x times 2x is 4x squared. Outside is -2x. Inside is -6x. And last is +3. And all this equals -4. Okay, I'm going to combine my like terms now, and I've got 4x squared minus 8x plus 3 equals -4. Quadratic equation's evident. So now I've got to get this quadratic equation equal to 0, so I'm going to add 4 to both sides. Where I end up with 4x squared minus 8x, and that's going to be plus 7, that equals 0. Standard form now, the equation is equal to 0, all good stuff. And now I can list my values for A, B, and C. So A equals 4, B equals -8, and C equals 7. All plugged into -b plus or minus the square root of b squared minus 4 times A times C. Well, you keep doing it this way by writing this formula down, you will certainly have it memorized. Remember, this is all over 2a. Okay, we do this for every problem, then after a while you'll know it off the top of your head. Okay, and let's plug in now. So I'm going to have -8, because that's what b is, plus or minus. Here I'm going to have b squared, so that's going to give me 64 minus 4 times a, which is 4, times c, which is 7. And that's all going to be over the 2a, which will be 8 when I get to that part. I want to figure this out first. All right, so I'm going to have 8 plus or minus, and let's see, square root of something's going to go there. That's going to be 64 minus what this is going to be here. So what is this, 16 times 7, I could say. 16 times 7, that's 112. That's what this is, so it's 64 minus 112. So I'm just going to subtract 64 of that. And that's going to give me 8 and 48, -48. So inside I'm going to have -48. And that'll all be over 2 times 4. Let's see, what was A? A was 4. So that'll be all over 8. Okay, this is where I'm at thus far. Here. And let's do something with this -48. So 48 will be broken down into, how about 6 times 8? And 6 will be broken down to 3 times 2. and 8 will be 2 times 2 times 2. All right, we're talking the square root here. So I'm talking the square root of 3 times 2 times 2 times 2 times 2. All right, for every 2 you take out 1, 2 comes out. Here's 2 more, so that 2 becomes a 4. And what's left is 3. 16 times 3 when I check that. So this is going to be 4 root 3, but we also have the square root of negative 1 here. So this square root of negative 1, that's my I. So I'll put it here for now. When I rewrite this mess, I'm going to have 8 plus or minus, and now instead of square root of negative 48, I'm going to have 4I root 3. And that's all going to be over 8. Okay. Now I want to factor out the top here, and I can factor out a 4, it looks like. So if I take out a 4, I'll leave the I there. When I take out the 4 and divide back what's left over, I've got 8 divided by 4 is 2, and that's plus or minus. 4I divided by 4 is I, square root of 3. And that's all going to be over this here 8. Okay. And then I'm going to simplify 4 over 8. 4 goes into 4 once, 4 goes into 8 twice. So now it looks like my answer will be 2 plus or minus I root 3 all over 2. And this will be my answer, final answer, simplified. Okie doke. Pretty slick. Okay, moving onward to example 6 today. In this problem, I don't have a quadratic here. I have a cubed variable, my first term. So looking at this over, when I see this alerts me to, is this a sum or difference of 2 cubes? All right, it's a difference of possibly 2 cubes. So 27 is a cube number, t to the 3 is cubed, and so is 8 a cube number. So I can factor this by knowing that it comes from, where does it come from? It comes from a binomial times a trinomial. Remembering where it comes from. And I want to fill in everything I know from here. So what do I know? I know the sign in the first parentheses is going to be the sign in the problem. The sign between the first and second term of the trinomial is going to be the opposite of the first sign. That's going to be plus, and the third sign or second sign in the trinomial is always positive. Like so. So my signs are set up. Now I want to fill in the binomial, and that means I'm going to take the cube root of 27t to the third, which is going to be 3t, minus the cube root of 8, which is 2. Okay, then filling in the rest of the trinomial here, I'm going to cube the first term, and that gives me 9t squared. I'm going to multiply the first 2 terms here together, and that's going to give me 6t. Okay. And the third term is the negative 2 squared, and that will be 4. It's always positive. So our signs are already determined here, remember that. And this is my factorization for this binomial times the trinomial. All right, and then lessons past, I said we usually can't factor that trinomial, but now we can, because of our advent of the imaginary number system. All right, so this first part is one of my answers. That's where that's going to come from. So I know ahead of time that t is going to equal, was that 2/3? That's one of my answers. But the real job now is to factor this 9t squared plus 6t plus 4. So I'm going to use the quadratic formula where a equals 9, b equals 6, and c equals 4. And that's what I'll use. For negative b plus or minus the square root of b squared minus 4 times a times c, all divided by 2a. All right, so let's plug it in here. So what am I going to have? I'm going to have negative, let me scoot that up a little bit more, a negative b, so that'll be negative 6. Let me change colors again. Negative 6 plus or minus, and the square root of b squared, which would be 36 minus 4, times a, which is 9, times c, which is 4. Okay, all over 2 times a. And so that's going to give me 18 in the denominator. Okay, I want to figure this out again, though, like I was talking about. All right, so we got 36 minus 4 times 9 times 4. So that looks like it's 36 times 4. 4, carry the 2, 12, is that 14? Oh, nice, I think. So I got 36 minus 144. So I'm going to subtract the 36. My answer will be negative. So I've got 8, 0, 108, and that's negative 108. Okay, all over the 18. So let's see. I've got negative 6 plus or minus the square root of negative 108, all divided by 18. So let's work on that negative 108, the square root of negative 108. So I see I got ahead of me coming, the I is going to come out. That's the square root of negative 1, but I got to simplify the 108. So what have I got there? I can say 54 times 2. All right, 2 is prime. 54 would be 2 times 27. That's 54. This 2 is prime. And the 27, I know, breaks down to be 3 times 3 times 3. And these are all prime, of course. So if I'm looking for the, let's see, I'll try it over here. The square root of these numbers here. What have I got? 2 times 2 times 3 times 3 times 3. All right, so the square root would be, for every 2 I take out 1. Here's 2 2's, take out a 2. Here's 2 3's, so I'll take out a 3. And what's left into the radical sign is the square root of 3. So it looks like this answer for this part of the numerator is going to be 6 root 3. Okay, so I'm going to put a line here and kind of section myself off like this so we know where we're going, to say when I copy this down, it's going to be negative 6 plus or minus the I is with us and the 6. I'm going to write that up as 6I root 3. 6I root 3. That's where the square root of negative 1. So don't forget that, of course. And all that is over 2 times a, and a we said was 9, I believe. Yeah, there's 9 there. So my denominator here is 18. Okay. I can factor out a 6 here. I could factor out the negative if I wanted to, or I could rewrite it to be negative 6 over 18 and simplify it. But let's see, if I write this up as, how about just taking the 6 out? If I took the 6 out here I'm going to have -1 plus or minus, what would I have? 18 divided by 6. Oh, I'm sorry, 6i divided by 6 is going to be just the I root 3. And that'll all be divided by the 18. And now I'm just going to simplify the 6 over 18. 6 goes into 6 once, 6 goes into 18 3 times. And herein lies my answer of -1 plus or minus I root 3 all over 3. And we're good. Okay, here's a couple application problems. This here is example number 7. And it's talking about if an object is thrown downward with an initial velocity of 20 feet per second, the distance, s of t, in feet it travels in t seconds, is given by this function, s of t equals 20t plus 16t squared. How long does it take the object to fall 40 feet? All right, so what is this saying? So an object is thrown downward with initial velocity of 20 feet per second, represented by that 20 times t. The distance, s of t, in feet it travels in t seconds, is given by this function. So we know that the function is s of t, that equals 20t plus 16t squared. Okay, that's that note here, that t is lower, like what they call that, lower, so it needs to be raised to the second power. That's just how it printed. So that's really t to the second power. All right, how long does it take the object to fall 40 feet? All right, so that is what the distance is. The distance is s of t, so I'm going to write this up as s of t is the same as height. Remember, on this graph, we're not using x and y's. So this axis, if I were to graph this, would be, messy, would be, if this is my graph, then this label would be t for the axis here. And the axis going up and down would be the height. So you'd use it in terms of t and h instead of x and y. All right, t is measuring the time. That tells you how high the object is given these circumstances. All right, so let's see, back to the problem. How long does it take the object to fall 40 feet? All right, so if it's going to fall 40 feet, then this s of t equals 40. So I'm going to write it up as 40 equals 20t plus 16t squared. And now I've got a form of my quadratic equation. So what do I do with this? I'm going to put this in the right form, in standard form. Okay, so that means the 40 will come over. This looks like it's just out of order. So if I subtract 40 from both sides, I'm going to write this up in standard form. So it'll be 0 equals, I'll put the 16t squared first, plus the 20t, and then minus the 40. And there is my equation so far, my quadratic equation. So this is where I'm at, given these conditions. And now what I want to do is factor that using the quadratic formula. Now I can continue doing this, but I know you got your calculator and such, but if you had to do this manually, what you would do is take out a common factor. Because all we're doing is solving for t now. So I can take out stuff, make these numbers a little bit smaller. And it looks like I can take maybe, not an 8, but how about a 4? If I took a 4 out, what would be left? I'd have 4t squared plus 5t minus 10. And I'll use these numbers in my quadratic formula. they're smaller. Easy to figure out. Okay, so now, and I can discount the 4 now. That's out of it because I'm solving for t. Remember, this is equal to 0. So now I can say that a equals 4, b equals 5, and c equals negative 10. Okay, and I apply it to negative b plus or minus the square root of b squared minus 4 times a times c all over 2a. So let's go ahead and fill it in. Negative b. b is 5, so this will be negative 5. Let's scroll up a little. Negative 5. Plus or minus, and then the square root of b squared, which is 25, minus 4 times a, which is 4, times c, which is negative 10. Okay, and I'll wait to put my denominator after I evaluate this radical. So this is going to be 25 plus 4 times 4 times 10. 25 plus, because I got a negative 4 times a negative 10 is positive 40 times 4. And that's 160. So I'm going to add these two together. And I get 185, it looks like. 40 times 4, 160. So now I've got negative 5 plus or minus the square root of 185 all over 2 times a, which is 8. So far, so good. Now it looks like I'm going to have to take this 185. I'll use this 185 and do what? Factor it. Okay, so I could say it is going to be 185, 2 factors of 185. Well, I could say 5 goes into 185. I don't have my calculator with me. 4, so let's make, so I have to do it manually. So that's 37. Oh, so this means I've got 5 times 37. Interesting. So this just is going to remain 185. 37 you can't break down, and neither can you 5. These are both what we call prime numbers. So if those are prime numbers, it's saying the square root of these two numbers. So it remains as 185. Okay. So what does that tell me? That tells me this is the answer. I can't simplify that any. So I'll leave it alone. We're done with that. Plus or minus covers both the answers. If you wanted to get a decimal approximation, you could do that. If depending on the problem. Okay. Done. And let's move on to the next one. Okay, example 8. This is our last example for this section. And we've got a company produces and sells copies of an accounting program for home computers. The total weekly cost in dollars to produce X copies of the program is C of X equals 8X plus 500. That's the cost it takes to produce X copies of the program. And the weekly revenue for selling all X copies of the program is R of X equals 35X minus 0.1X squared. How many programs must be sold each week for the weekly profit to be $1,200? Okay, so what do we know here? They're asking for the profit, but they're giving us the revenue and the cost. R is for revenue, C is for cost. So I could say that the profit is equal to the revenue minus the cost. Okay, that's where the profit comes from. Equals the revenue minus the cost. Okay. So given that's the case, how about we go and plug this in? So the profit, they're looking for the profit to be $1,200. So the P is the profit, so that's going to be 1,200. That equals the revenue, and the revenue is explained as R of X, which is 35X minus 0.1X squared. And that's the revenue minus the cost. Minus the cost, and the cost is here. And that's going to be 8X plus 500. Okay, and the weekly revenue is the revenue, we got it. So it's the revenue here. Here's the revenue minus the cost equals the profit. And here, this is in our section of adding and subtracting polynomials. Here, I've got to subtract that binomial. So what do I have to do? I have to distribute the negative. So let's kind of clean this up here a little bit then. Okay, so it's going to be 1,200. That's going to equal 35x minus 0.1x squared minus 8x. So let's see, if I write this up, it's 35x minus 0.1x squared minus 8x minus 500. I'm distributing the -1 to here and to here. I'll gather my like terms, and I'm going to end up with, well, let's put the x squared first term here. So 1,200 equals what? Negative 0.1x squared. And then that's going to be 35 minus 8 is going to be 27. So that's going to be plus 27x minus 500. And this is my quadratic equation thus far. We're getting there. So how about if I subtract the 1,200 now to get it equal to 0, and then I'll have my numbers for my quadratic formula. So 0 is going to equal -0.1 x squared plus 27x minus 1,700. And now I can list my ABCs. So A equals -0.1, B is going to equal 27, and C is going to equal -1,700. Okay, quadratic formula. So I've got negative b plus or minus the square root of b squared, so that's 27 squared, minus 4 times a, which is -0.1, times b, which is -1,700. Let's go that way. That is not right. Let's see where I messed up here. Okay, so let's fill in our numbers doing that, and oh, I forgot my negative b, which is -27. So I can do this and bring that back and write this up as -27. Okay, I know it's over my denominator of 2 times -0.1, when I get to that. I know it's going to be 0.2 in my denominator, but let's figure this out. All right, so I've got negative 27 plus or minus, and then here it's going to be 27 squared, which is 729 minus, and this is going to end up, this minus is this minus, that sign. This will end up being positive. So it's going to be minus 4 times 1700 times negative 0.1, which, doing the arithmetic there, should give you 680. Okay, and that's going to equal 729 minus 680 is 49. So I'm going to have negative 27 plus or minus the square root of 49. Remember, this is all under the radicals still. And that's going to be all divided by 0.2, which is A is negative 0.1 times 2, which will give you 0.2. All right, so let's see. Moving forward here, I'll bring this down, and we'll say this is negative 27 plus or minus 7 all over 0.2. Okay, let's split this up now to say negative 27 plus 7 is negative 20 divided by 0.2. Okay. And how about the, let's see, where am I here? Negative 27 minus 7, which is negative 34 over 0.2. Okay, negative 27 plus or minus 7 divided by 0.2, I get this. I made one little mistake up here. I just realizing that this was, as I had indicated here, A, so that if that's 2A in the denominator, it's 2 times negative 0.1. So that means my denominator is negative as well. Negative 0.2. Negative 0.2. So now I can get my solutions here to be for 20 divided by 0.2, that equals 100. And 34 divided by 0.2 is going to give you 170. So here are our two solutions for that problem. The weekly profit will be $1,200 if the company produces and sells 100 programs or 170 programs. And that's how we are answering that question. All right, so that's fine. Everything looks pretty good. Arithmetic was done right. And that's it for section 7.2. So good luck on it. I hope you understand, especially these comprehension problems or application problems. They're never easy, but we have to continue to work on it, especially if you're going on to the next math class, one at a time. All right, that's it for now. Have a great day.